Hi, how are you doing? Welcome to a new video once more. And in this video, we'll be starting another topic, which is trigonometry. Trigonometry is one of the topics you'll find in various engineering courses, mechanical engineering, electrical engineering, and civil engineering, and building technology. And for that reason, I'll be using past papers from various engineering courses so that I can help you in your revision. And always remember to subscribe to the channel, like the video, leave a comment on the video so that we can assist the channel grow and to be able to make more content for you. That's very key. Commenting and liking the video help the video to be promoted to other people, which help the channel grow. For our first question, we are going to start with a graph in building technology, question 5a. And I'm not going to write the entire of this question because it's a bit lengthy. And we are told a surveyor sights 2 points directly ahead. Both are at an elevation of 18.5 meters, lower than the point from which he observed them. How far are the points if the angles of depression are 13.5 and 13.5 degrees and 21.3 degrees respectively? So we are told the points are 18 meters lower from the points where he observed them. So let's assume the surveyor is here. This is the points are 18.5 meters from the points where he observed them. So one of the points must be somewhere here. Another point probably is somewhere here. The angle is 13.5 degrees and the other one is at 21.3 degrees. And the question is, how far apart are the 2 points if the angle of depression is 13.5 degrees and 21.3 degrees? So we are being asked how far apart are the angles, are the 2 points. We know this is 90 degrees. If you have the adjacent side and you have the angles, it's possible that we can get this line. Because we know tan of an angle theta is given by opposite over adjacent. We have the tan of, say, the first angle is 21.3 degrees is equal to opposite side, which we want. This is opposite. The other of this side, opposite, which is the opposite side, but you can call it from here. All this is the opposite one, and this is also another opposite, maybe 2, so that we can differentiate them. Opposite one over the adjacent side, which is 18.5 meters. Be working in meters, so we can see 18.5 tan 21.3 degrees is equal to opposite side, or simply the opposite side is equal to 18.5 times tan of 21.3 degrees, which is the opposite side for the bigger angle is 7.2873 meters, and the other side, opposite 2, simply using the same working, the second side is 18, the other distance is 18.5, of course we know is in meters, times tan of the second angle, which is 13.5 degrees, is 4.4415 meters. So that if you have to work out that, the difference between the two sides will be, this is the distance you want from this point to this point. How far are the 2 points apart? Maybe let's call this point A and this point B. So that AB is equal to opposite 1 minus opposite 2, which is 7.2873 minus 4.4415 meters. All the measurement, we are working in meters, so that is in meters. So that the result is 2.2 2.8458 meters. So that's far. The 2 points are apart. Question B, we are told B Roman 1. Prove that sin x or over 1 plus cos x plus cot x is equal to cosec x. If we start with the left hand side, taking the left hand side, we told sin x all over 1 plus cos x is equal plus cot x. What is cot x? Cot x is 1 over tan x, but we know tan x is equal to sin x all over cosine x. So cot x, which is equal to 1 over tan x, must be cot x is equal to cos x over sin x. So that here we have cos x all over sin x. Let me remove this so that we can create more space for working. Now we find the LCM, which will be 1 plus cos x multiplied by sin x. If we now take this value divided by this, we get sin x times this sin x. So we have sin x times sin x plus this value, the order of this divided by this, it will be 1 plus cos x times now cos x. So you have cos x times 1 plus cosine of x, which will be sin squared x plus, open the bracket, cosine of x plus cos squared x, cosine of x plus cos squared x. Now if we divide through with 1 plus cos x times sin x, we know, using the fundamental trigonometric identity, we know that, but sin squared x plus cos squared x is equal to 1. So we can say this sin squared x, this, we have sin squared x plus cos squared x plus cos x all over 1 plus cos x times sin x. But the whole of this value here is 1. So you have 1 plus cos x all over 1 plus cos x multiplied by sin x. So this can cancel out with this. That now the result is 1 over sin x. But what is 1 over sin x? You know, 1 over sin x is cosec x. By working through the left hand side, it has equated with the right hand side, which is also equal to cosec x. Roman 2 of the same question, Roman 2 of B, we are told, so for x in the equation 6 sin squared x plus cos 4x, no, not cos 4x, but cos x is equal to 4 in the, I hope that is not outside my camera range, in the range x rise between 0 degrees and 360 degrees. We can say here 6 sine squared x. If you bring 4 to this 4, you can bring it to the other side of the equation. Cos x plus 4 is equal to 0, but we know that according to the trigonometric fundamental identity, sine squared x plus cos squared x is equal to 1. So from this we can see sine squared x is equal to 1 minus cos squared x. From which we can say 6 into bracket, instead of using sine squared x, we use 1 minus cosine squared x, 1 minus cosine squared x plus cos x plus 4 is equal to 0. Now let us make use of this space. If you now open the bracket, it will be 6 minus 6 cos squared x into bracket plus cos x plus 4 is equal to 0. If by that you want me to take you through an online class, you can always send me an email through the email given on your screen. Let us first of all combine the terms. We will have negative 6 cos squared x plus cosine of x, this will be plus 10, is equal to 0. Here this will be negative 4, not 4. Bring the 4 to the other side of the equation, it will be negative 4. And here it will be negative 4. Because it's positive here, bring it to the other side of the equation to be negative value. So that this is negative 4 and this will be positive 6 and negative 4, this will be positive 2, not 10, is equal to 0. But we want to work with this value when it's positive, so we can multiply through by a negative. It will be 6 cos squared x minus cosine of x minus 2 is equal to 0. So that now when you say that y or cosine of x to be y, obviously cos squared x will be equal to y squared. So that now you have 6 y squared minus y minus 2 is equal to 0. The product here is negative 12 and the sum is negative 1. So we want two numbers that we can multiply to give us negative 12 and the sum to be 1. Those numbers will be negative 4 and positive 3. Because when you multiply negative 4 and positive 3, it will be negative 12. When you multiply, you add them, it will be negative 1. So we have 6y squared plus 3y minus 4y minus 2 is equal to 0, which will give us, we factor out 6y to get y, not 6y. If we now factor out 3y we will get here you have 2 y plus 1. We factor out, again we factor out 2, we will have, or negative 2, 2y plus 1. 2y plus 1 is a common factor, you can factor it out. 2y plus 1, close that bracket. You have 3y minus 2 is equal to 0. So if you have two numbers that you are multiplying and the result is 0, either one of them could be equal to 0. Now we put the 2 with 0, it will be 2y plus 1 is equal to 0, meaning 2y is equal to -1, y is equal to -1/2, or cosine of x is equal to -1/2. We also have 3y minus 2 is equal to 0, meaning 3y is equal to positive 2, or y is equal to 2/3, or cosine of x is equal to 2/3. So now we will solve for the 2. Cosine of x is equal to -1/2 and cosine of x is equal to 2/3. From which we can say cos x is equal to -1/2, and we apply cancellation equation. Cos inverse cos x is equal to cos inverse -1/2, which is x. Cos inverse cancels out cos x to give you cos inverse -1/2. We'll write on this side of the whiteboard so that we can have some more space. Now we know that the three trigonometric functions, all of them are positive in the first quadrant, only sine is positive in the second quadrant, only tangent is positive in that quadrant, and only cosine is positive in the fourth quadrant. We'll regularly be using this, so I encourage you to have it in your mind. The fact that this value is negative, it tells us our answers will be one in first quadrant, will be one in second quadrant, and another one in third quadrant. So for the time being, let us work with x is equal to cos inverse a half. If now using your calculator, you get cos inverse of 0.5, this will be 60 degrees. Or your angle, your tentative angle is 60 degrees, but the actual angle is in second quadrant. And how do you get angles in second quadrant? You say your x is equal to 180 degrees minus the angle you got here, which is 60 degrees, which is 120 degrees. Also, the other angle, because you are so told to solve inclusive, x is angles in this quadrant are given as 180 degrees plus that angle that you got after getting cos inverse a half, which is 60 degrees. So the other angle will be 240 degrees. We are not done yet because we still have another equation. We still have cosine of x is equal to 2/3, or if you apply the cancellation equation, x is equal to cos inverse 2/3. Let us work out using a calculator. We have 2 divided by 3 is equal to 0.66. Cos inverse of that is 48.189 or 0.9 degrees. Notice our value here is positive. Our cosine of x is positive, meaning if you get the angle x, that angle x, because this value is positive, it will be an angle in the first and fourth quadrant. So we expect our answers to be in the first and in the fourth quadrant. The other value of x will also be equal to angles in the fourth quadrant are obtained as 360 degrees minus that particular angle that you found using your calculator, which is 48.19 degrees. So if you take now 360 degrees minus our answer, this will be x will be 311.8 1 degrees. Now, so we have 4 answers. We have x can be equal to 120 degrees or 240 degrees or 48 degrees, 48.19 degrees or 311.81 degrees. So that's how we go about that. Remember, if you want me to take through any topic in engineering mathematics, that is in building technologies, civil engineering, electrical, mechanical, send me an email through the email shown on your screen or in the video description.